So next, coming to us from Delta, Colorado, Automated Irrigation Systems, Mr. Kelly Cox.
Thank you very much for sharing your time with us tonight. My name is Kelly Cox, and I'm a software developer that has a passion for fixing things. And I also happen to have a little bit of irrigated land that my boys played on mostly and irrigated when I forced them to. And then guess what? All of a sudden one summer, nobody came home. And I had to go irrigate, and I learned something really quick. First off, it's not just about water. It's about water, labor, and energy. And the labor and the energy are two pieces that are trade-offs that nobody really talks about a whole lot in this industry. The water is really simple. As you see on the right side of this slide here, that little teeny slice, 1% of all the water on Earth is fresh water that's available for human consumption. Just 1%. And 70% of that little slice is used in farm irrigation worldwide. So conservation of water is a must. It's simple. But the labor and the energy pieces is a part that is really a big trade-off. And the conservation, this is what happens if someone waters too much. The water percolates deep, it brings up salt, selenium, heavy metals, and then runs off with the topsoil, the pesticides, and the fertilizers right into our water supply, which then we have to clean. So irrigation itself hasn't changed in centuries. My boys did it this way. And when they didn't come home, I went out and looked at that and thought, that's crazy. No wonder they whined. So I had a choice. I could go into something called siphon tubes, and what I did was I bought pipe like this, because a lot of my neighbors had it. And they all told me this was going to really cut back on your labor. Well, they lied to me. And it still takes a lot of labor, and you have to go out in the field, and you have to take a hoe or a golf club, and slide these things back and forth, and every time you want to change the watering, you got to go back out again, and again, and again. And this is what happens when a software geek tells his wife, I'll be back in 15 minutes, keep lunch hot. This is what I look like most of the time. And I whined a lot, just like my boys did. And my wife, politely, if she's watching, said, get over it. And this was my other choice. And when I talk about the labor or the energy, I had two choices. I could buy something like gated pipe, spend a lot of time in labor, or I could buy a very expensive center pivot. These are those big, huge crop circles that you see when you're flying around. And these things cost a lot to build, huge factories, a lot to distribute, install, and then they run basically 24 hours a day, all summer long. Heavy energy cost, heavy carbon footprint. So those are my choices, and I went for the cheap one with a lot of labor. And then, after listening to my wife, I finally got over it, and this is what I did. I cut up a whole bunch of my boys' RC toys, and a Legos robot, and a bunch of Ace Hardware store parts, and I made this water widget. And what I did was strap it on, and I could then go out, not all the way to the field, and I could stand a half mile away with a little radio controller from an airplane, and I could open and close gates. And it was really slick for maybe 24 hours, because I still had to go out. And I'm a software developer that's used to controlling things remotely. So within weeks, I moved up and I'd made 4 different models, each one consecutively better, quickly, that I could then put in a schedule. And that schedule could water day or night. I could be sleeping, I could be off visiting, I could be, riding my motorcycle, I could be hiking. And that's what I came up with. And a neighbor came by. The neighbor had 17 miles of pipe. And he was going to his head gate, and he said, what do you got? I told him, he got excited. He said, build me a bunch. I'm a software guy, I'm not a manufacturer. So I told him he was crazy. Bring his hired hands over, I'd show them how to make them. And he showed up a few weeks later with the USDA and NRCS engineers instead. And they got excited, they convinced me that I was really onto something, and they introduced me to the Bureau of Reclamation. The Bureau of Reclamation immediately convinced me that I needed to go to CSU Experimental Farm and start a formal field test with them monitoring. And that CSU farm is over near Grand Junction. And what we learned a lot. First off, this short little clip will show one of those gated pipes. It's very static, the one on the left. The only way to change that water, turn it on, off, or increase or decrease, is to drive back out in the field, another big piece of energy use. And the other one you'll see is slowly increasing and slowly decreasing. I sped it up a lot, but that's a water widget that we were testing. I think that was probably model 6 or 7. That was one of the summers at CSU. And that just shows you how unattended we can water with very, very low labor and very, very low energy. So what we learned at CSU over 4 summers was that we save a lot of water, which was the Fed's initial goal for me. And 65 to 75%. So that would basically flop that amount of fresh water of 70% irrigation, 30% for human usage. It would basically swap that if we did that everywhere. What we also learned was that it decreased dramatically the runoff, the deep percolation, and the messing up of putting all that toxic stuff back into our water supply. The reduced field visits is also a big dramatic decrease. There's no need to go out in the fields at all anymore unless something breaks. So it's also solar powered. It's extremely low energy usage. It's got a small battery that we expected lifetime is 10 to 12 years. The only time you have to change anything is in that 10 years. So it's also light manufacturing. Unlike the center pivots and those kind of pressure systems, the manufacturing itself can be done right here in this auditorium and anywhere in the world where this kind of watering is needed to take place. Anywhere there's flood irrigation, these can be built. There's, of course, a software app for that. I know you're shocked. But it does more than just the scheduling of the watering. It tracks all usage, all rates of usage. So there's a permanent log of all the water that you've used, which will help you project in your future watering. It helps you do your annual legally required government reporting that's usually just guessed at. And that app also allows not only the knowledge of the farmer to be permanently put into his fields and into the widget, but also allows an automatic override if the farmer, selects an optional sensor. So you can have sensors anywhere in the fields, on all your head gates, all the way up the weirs and all the canals, so that if it starts raining and you've said, it's time to start watering, and you set it on a 4-day schedule and it's going to water for 6 hours, those sensors can automatically turn the widgets off or on if it's hot and dry and windy. And it can also then optionally open and close the head gates all the way back up the canals. So the software app has a lot to control. So what we've seen here is that there's always been this big issue in the last few decades of labor or energy. And we've solved it with this water widget. And the USGS annual survey this year in 2018 says that there's 23 million acres just in the western U.S. of flood irrigation still. Of that 23 million acres, 10 million acres is already in that gated pipe I showed you that I bought. So our phase 1 is just to retrofit that 10 million acres. Phase 2 would be to go after the rest of the 23 million acres. And phase 3, the whole rest of the world that has the same problem that we do. So that 10 million acres equates to about 130 million water widgets. A software geek, it's hard to comprehend. And there's healthy margins in this. We hope to build it right here on the western slope and put people back to work. The unit is already patented, and that mobile scheduling app that we've got is just another piece of the revenue picture, and maybe even the biggest piece. Of that 130 million widgets in phase 1 only, this is our goal in the first 5 years. Start slow as we see the differences between prototyping and production, and then ramp up as rapidly as possible to the first 1 million units in 5 years, and then continue that growth until we fill that 130 million acres. So, our goal, my wife and I, is to help feed the world with less water, less energy, and less labor. And if any of y'all have any background or experience or even a desire to be a part of this, we need a team. I'm a software geek. We need a team that understands manufacturing, especially in injection molding. We need a mechanical engineer. We need an electrical engineer for circuit board enhancements. I've been kind of faking that on my own. And we need someone that'll help fund the initial startup. We need the factory to get started. I mean, just the first 10,000 widgets the first year alone is going to be a hurdle. So that's what we need. If this resonates at all, please come visit us later at the Overlook Cafe. This is our contact info. Thank you very much.
Yeah, Kelly, come grab a chair with us. You know, he said he's a geek, but I think he's actually technically a nerd. That means it's an acronym. It means notably excelling in researching deep subjects. Look that up. I found that on the internet, so you know it's true. So, panel, what do you got for questions?
First and foremost, I think this is incredible. Thank you so much for putting this together. With us in the arid West having so much water problems, it's certainly timely. But my big question is, why is it not already here?
Oh, that was my question when my boys left. I went and asked all the neighbors. I was like, I can't believe you guys still do this, with a hoe. And they said, no, we're up past hoes. We use golf clubs now. And I went to buy what I thought is, I went to buy an automated, mud mover, and it wasn't available. It just wasn't. I mean, Grand Junction, I went all over the place. And I asked everybody, and they said,
because Rainbird, all these different sprinkler manufacturers, they have everything that's app controlled, but nothing in this world.
no.
Well, great job.
And the valve patent specifically was on autonomous valves. Every unit's a master.
Interesting. Well, wonderful idea. Thanks.
Yeah, I think this is a product that could really help, obviously, the southwest of the country, but also, around the world. Because this has been, farmers have been doing the same system for so long, how easy is it, do you think, to convince other farmers to move to this system, and how easy is it for them to move to this other system now?
Well, the first phase of this would be quite simple. Those little slide valves have to be replaced, I have found out, every year or two anyway. They've got to pull those apart. So the time that it takes to replace that little slide valve would be the same amount of time it takes to mount one of these things. And it would qualify for one of the federal farm subsidies that they're getting now for all their irrigation and tractors, anything that's an automation piece. This will qualify also. And the ease of use on it, everybody that I've showed it to across 5 states so far in the last 4 or 5 years, I've got multiple letters of intent. I just have to get it into production. I can't keep making 3D printed prototypes.
So that leads to the last question. What does production look like for you guys, and what hurdles do you foresee in the next 1 to 2 to 3 to 4 to 5 years?
The biggest hurdle is a software geek trying to figure out how to manage manufacturing.
So once you find it, because you will, and then what's going to happen from there? You're going to find that guy or that girl.
I think we need a team.
Yeah.
We need quite a few people. Then just expand and grow. I've been making all the sensors that I was talking about, I've been making them myself and putting them, so I've got things stuck in the creeks and in the ditches and on head gates, and the neighbor came and said, how come that big red wheel's missing? And I said, well, because I had a BMX bicycle hub mounted to it, so I could control it from my house.
So most of his neighbors are missing parts from vehicles and cars, and that's how we do it in the Wild Wild West, right? That was a joke. Don't actually do that. All right, question for you, and I know we want to keep this short on time, but I love the fact that you tie together water conservation, drought here in Colorado. Of course, saving water would be wonderful for ecosystems and downstream users. Energy and labor were kind of things that keep coming back up and up, right? And so I think we would love to hear an example of maybe what this could save somebody on that water, on the energy side, maybe where it's an energy intensive thing and they could have some significant savings.
Well, I've talked to a lot of farmers, and so the figure that I'm going to give is just it ranges, and it depends on where they're pumping their water from, how far they have to pump it. But my neighbor that I pass every day, he had a sod farm, or for a few years he was growing sod, and I think he's doing onions this year, but he had a single field in sod with one of those center pivots, which we all subsidize as a tax subsidy, and it was costing him about $20,000 per summer just for the energy for just one field to run the pressure and the filters and all that. And we estimate that his average cost to run a water widget for that same field would be about $200 per year.
What was the first number?
It was over 20,000 for 2 years, and then he yanked out that center pivot and sold it to somebody, or gave it away. He was so mad at it. It cost him more to run it than the additional yield that he got out of it.
Well, I don't have any special skills, but I want to be on your team. Yes. I think we're a little bit over on time. Sorry to cut you off on that one. Thank you so much, Kelly. That was fantastic.